Okay, students, welcome once again. So let us give a brief idea of this example. We have left this example, now we will continue it. In North Delhi, there are 20 colleges, 50 schools. So there are 20 colleges and 50 schools. Each school and college has one peon, 5 clerk, 1 cashier, right? 1 peon, 5 clerks, and 1 C for cashier. Each college, in addition, has one accountant and head clerk, but the one accountant and one head clerk possessed by the college, but not by the school. Be careful. One accountant and one head clerk is there in college only, not in all schools. The monthly salary of each of them is rupees 100 for peon, 150 for clerk, 250 for cashier, rupees 300 for accountant, and rupees 350 for head clerk. Find the total number of posts of each kind in schools and colleges taken together. Right? So consider here what we are having. We are having two categories: 20 colleges and 50 schools. Right? Colleges are having school and colleges are having one peon, 5 clerks, and 1 cashier. But colleges in addition are having one accountant and one head clerk. They are not possessed by the schools, right? Their monthly salaries are also given. You have to find out the total number of posts of each kind in schools and colleges taken together. So consider the row matrix A is equals to 20 and 50, right? This matrix simply represents the number of colleges and schools, right? There are 20 colleges and 50 schools. They are being represented in the form of a row matrix. Now let us take B is this matrix. See what they are saying. Colleges are having one peon, 5 clerks, 1 cashier, right? They are also possessed by the school, 1, 5, 1. But each college in addition has one accountant and one clerk. So one accountant and one clerk, they are possessed by the colleges, but they are not possessed by the schools. That's why we have taken here 0 and 0. Clear? Why we have taken here 0 and 0? Because schools are not having accountant and clerks. See, where columns represents the number of peons, clerks, cashier, accountants and head clerks, while row represents the colleges and the schools. The first row represents the employees in the college. The second row represents the employees in a school. Now, to find out the total number of employees in schools and colleges altogether, we will multiply A and B, and the product of AB is coming out to be 70, 350, 70, 20 and 20. So what this represents, overall the employee in colleges and schools, there are 70 category 1, that is peon, there are 350 clerks, there are 70 cashier, there are 20 accountants and there are 20 head clerks, right? This is how we can determine the total number of employee altogether in schools and colleges. Now take part 2. In part 2, what we want to calculate? The total monthly salary bill of each school and college separately, right? So let us take C as 100, 150, 250, 300 and 350. This is what? This is the monthly salary paid by all the 5 types of employee, right? It is given in the question, where the column represents the monthly salary of peon, clerk, cashier, accountant and head clerk, right? This is given in the question. Then what is B? See here, B is equals to the total number of employee of the schools and college. This is B, right? If we multiply B with C, so we will get here the product as 1800 and 1100. Thus the monthly salary bill of each college is rupees 1800 and each school is rupees 1100. So the amount 1800 is the total expenditure of the college and 1100 total expenditure of the schools, right? Case 3, the total monthly salary bill of all these schools and colleges taken together. In case 2, we have calculated them separately, but in case 3, total monthly salary bill of all these schools and colleges taken together. Now, we want to calculate the combined income, right? So, BC is separate, right? To make it combine, what is A? Look at here. A is equals to number of schools and colleges. So, if we multiply this BC, this is separate. If we multiply this BC with A, total number of schools and colleges, then what we will get? We will get the total monthly salary bill of each school and college taken together. So, this matrix 1800, 1100, this simply represents the total monthly salary bill of each school and college separately. If this separate income we are multiplying with the matrix A, which represents the number of schools and colleges, then we will get the total monthly salary bill of all these schools and colleges taken together. So, A, B, C, what you will get here, A is 2050 and BC is 1800 and 1100. Multiply these two, 20 into 1800 is this, 50 into 1100. So, this is 18 into 2, 36,000, 55,000, sum of these two, that is 91,000. So, this amount actually gives the total monthly salary bill of schools and colleges taken together, right? This is how we can use the theory of matrices or matrix algebra to find out the solutions of the various problems which we generally encounter our business and industry areas. Let us take this case. Here A is equals to 1, 2, 3, 2, 0, 2 and B is 1, 1, minus 1, 2, 0, minus 3. So, do not read, say this is A and this is B, this is C. What we are having? We are having 3 different matrices and they are of different order also. Then show that A, B, C, A, B of C is equals to A of B, C, right? And you know what is this? When we started the matrix multiplication, this was a property which is known as associativity, and you know that the matrix multiplication is associative. So, for these 3 matrices we have to show that whether this property is satisfied or not. Now, it's very simple. What does it mean? First, find out the product AB by multiplying A with B. See, we are multiplying A with B, we are getting AB as like this, and then multiply this matrix AB with C. You will get a matrix, right? What is the, this is the left hand side. What is the right hand side? First multiply BC, you will get a matrix as a product. Then this product should be multiplied with A. So, both this matrix and this matrix should be equal. This is the meaning of actually the associative property. See this, AB is what? AB, multiply A with B. So, the first row of this should be multiplied with this, right? Very simple. I don't want to explain the same thing many times. Then multiply the first row with this and multiply the first row with this, and the same with the second row. Second row with the first column, second row with the second column, second row with the third column, and finally the product of these two you will get AB as a matrix this. And finally multiply this, the product AB with the matrix C. See, this is AB as it is, C is given as this, multiply this with this. So, the first row should be multiplied with the first column of the second matrix. Then first row should be multiplied with the second column of the second matrix, and then so on. So, you will get the product of A, B and C is equals to this, right? This is your left hand side. So, left hand side we have achieved. Now, find out the right hand side. In right hand side, first calculate BC, that is when B and C are multiplied together. See, B and C are multiplied this as usual, as I have explained many times. The first row of B should be multiplied with the first column, then the first row of B should be multiplied with the second column. Then take the second row of B, multiply it with the first column and then second column of C, and then take the third row of the matrix B and multiply it with the first and second column both. You will get the product as this. Now finally this is BC, so multiply this VC with A. So this is A, this is BC, and the product of these two is this. So this matrix and this matrix C both are same. Therefore the left hand side, that is AB of C, is always equals to A of BC, and we know that this is a property which is known as associative property, which is possessed by matrix multiplication. This is also another property. Verify that AB plus C is equals to AB plus AC if A is this, B is this, and C is this, right? You know what is this property? A B plus C is equals to AB plus AC. This is known as distributive property. So matrix multiplication is also distributive. So for any three matrices A, B and C, we will verify A, B plus C is equals to AB plus AC. This can also be written as A plus B of C. This must be equals to AC plus BC. This is property 1, this is property 2. So these are the two properties which we already discussed when we were discussing the properties of the matrix multiplication as distributive property, right? So we have to show that here AB plus C is equals to AB plus AC. Now very simple, what we want to do here? See, we want to show that A of B plus C is equals to AB plus AC. We know A, we know B, we know C. Take this is your left hand side, this is your right hand side. And what we have to do in such cases or in such questions, find out the left hand side and then find out the right hand side. Both sides should be equal. So how you will calculate the left hand side? What we will do? See from here, first sum of these two matrices, find out B plus C, sum of these two, right? And then this sum should be multiplied with matrix A. You will get here a matrix, right? Whatever you get, then take the right hand side. Multiply A with B to get the product AB. Then multiply A with C to get the product AC, and then add up these two, you will get a matrix of these two. What should be required? This matrix should be equals to this matrix. It will show that the left hand side is equals to right hand side. The same we have explained here in the example. See, first we find out B plus C, right? Sum of these two matrices. This is B and this is your C. You know how two matrices are added? They can be added by adding their corresponding elements. Since their orders are same, so we can add up the corresponding elements. Corresponding elements means 3 should be added to 2 as 5, 0 should be added to 3 as 3, 1 should be added to 1 as 2, right? Likewise, second row, 2 should be added to minus 1, 2 minus 1 is 1, 5 should be added to 0, 5 plus 0 is 5, 3 should be added to 2, 3 plus 2 is 5. Likewise, the third. So first we will find out B plus C as the sum of two matrices. Then as I explained, this B plus C should be multiplied with the matrix A, right? So this is the matrix A and this is your B plus C. Multiply these two matrices by using the same technique of the multiplication. So you will get A, B plus C, the matrix. This is your left hand side, right? LHS. This matrix is your LHS. Now come to right hand side. Right hand side contains AB. So first find out the product AB. A is known, B is known. Multiply these two product matrices AB as usual. So AB is this matrix, right? And then AC is this matrix. Now add up this matrix plus this matrix, AB plus AC. This matrix is added to this, you will get this. This is your right hand side, right? So see, the right hand side matrix and left hand side matrix both are same. Therefore, A of B plus C is equals to AB plus AC. So we have verified this property for these three matrices. You can verify yourself this property also for these three matrices, right? This is also known as distributive property. Say if, take this example, if A is equals to 1 0 0 1, B is 0 1 minus 1 0, then show that xa plus yb, xa minus yb is equals to x square plus y square plus a. Good. This is a good question. What is given here? First see. We have given here a matrix A, right? A is what? 1 0 0 1. This is our A. And B is what? B is given as 0 1 minus 1 and 0. See, two matrices are given to you, then you have to show that xa plus yb into xa minus yb is equals to x square plus a square into a. So just think over it, how we can prove this or how we can show it. xa is there, xa plus yb. So anyhow, first we will try to find out xa, right? So naturally, if A is there, this matrix, what does it mean? XA is what? XA means multiply this matrix A with X. So multiply this matrix A with X means all the elements of this matrix should be multiplied by X. That is known as the scalar multiplication. So XA is what? X into 1 is X. This is 0, this is 0 and this is X, right? See, this is A and then XA is this matrix. Similarly, this is B, YB will be what? Multiply this matrix with Y, so 0, Y minus Y and this is 0. This is B and YB is this, right? Up to here, everything is clear. So we have calculated XA as well as XB. Now, simply add up these two. XA plus YB. What is XA? XA is X0, 0, X plus YB is 0, Y minus Y and 0. Add up these two. XA plus YB, this is equals to what? X plus 0 is X, 0 plus Y is Y, 0 minus Y is minus Y, and x plus 0 is x. Clear? Up to here it is clear. See, xa plus yb is coming out to be this matrix, x minus y, y minus x. So naturally, if we calculated xa plus yb, then what is the value of xa minus yb means difference of these two as usual, that is x 0 0 x and minus what is yb? 0 y minus y and 0. So this is x a minus yb, this is equals to what? X minus 0, here x, 0 minus y, this is y, 0 minus minus y, this is plus y, 0 minus 0, this is 0. Okay. So xa minus yb, sorry, 0 plus x is x. 0, this is x, x minus 0, this is x, right? Now xa minus yb is there, xa plus yb is there. Now what we have to do? Multiply these two, xa plus yb and xa minus yb. This is equals to what? This matrix x, y minus y and x. This is xa plus yb, and the second matrix is what? X, y minus y and x, right? Clear? Now you can find out the product of these two, that is xa plus yb and xa minus yb. This is equals to, multiply these two, x into x is x square, y into y is y square. So x plus y square. Now multiply the first row with the second column. X into y is minus xy, y into x is plus xy. Now come to second row. Minus y into x is minus yx, plus x into y is plus xy. And here minus y into y is y square, and x into x is x square. This is the product of these two. This and this will cancel out, this and this will cancel out. So what is left here? We will get here x a plus yb and x a minus yb. This is equals to what? X square plus y square, 0, 0, and x square plus y square. Now you can take x square y square common. X a plus yb and x a minus yb. This is what? You can take x square plus y square common. What is left here? 1, 0, 0, 1, right? And see, this is what? X square plus y square. This is the matrix A. So xa plus ya into xa minus ya is equals to x square plus y square into a. This is how we can prove this very easily. Now this is also an example. Prove that the matrix A is equals to this. Satisfies the relation a square minus a plus da plus ad minus bc of I is equals to 0, where I is an identity matrix of order 2 and 0 is a null matrix, right? This is what? This is a kind of matrix equation. I have told you the matrices behaves like numbers. So in numbers we have many equations in variables x and y. So here in place of variables we are having matrices, so they are known as matrix equation. So 0 here will represent the role of a null matrix. It's not a number like 0, right? So if what is given here, if A is any matrix, then show that this matrix satisfies this relation. It is very much similar to the question if I say that x is equals to 5 satisfies the equation given like this. Yeah, or if x is equals to 1 is the root of the following equations. So what we did, we put simply x is equals to 0 in that equation. If it is satisfied, then it shows that x is equals to 1 is the root of the given equation. So same thing we will do here. We have to show that this A satisfies this relation. Means if we will put A in this equation, the left hand side and right hand side should be satisfied. Okay, see what we want to do. A square, first find out A square, right? So how you will A is given to you, this is A. Now find out A square. A into A, you will get A square. We calculate first A square, then find the value of A plus D and A. A square minus A plus D and A. So A square is this, A square minus A plus D and A. What is A? A is this. So A square is this minus A plus D. See, A square, what we did here, A square is this, A square plus BC, AC plus CD, AB plus BD and BC plus D square. This is your A square minus A plus D, keep as it is. And what is the value of A? A is A, B, C, D, right? So we reach up to here. Now simplify this. Simplify this means what? Multiply this A plus D inside this bracket, right? So what you will get? A plus D into A plus D into B, A plus D into C, A plus D into D. So this matrix will remain as it is without any change. This you see, multiply this A plus D with all the elements of this matrix. So you will get A plus D into A plus D into A first, A plus D into B, A plus D into B, A plus D into C, A plus D into C, and A plus D into D, A plus D into D. Now subtract these two matrices. After opening this, you will open this, open it like this, A plus D of A. This is equals to what? A square plus AD, right? Open this bracket. And then take the difference, you will get here A square plus BC, AD plus BD, AC plus CD, BD plus BC plus D square. Are you getting what I am telling you? First expand this bracket, A plus D into A into A square plus AD. Then subtract this matrix with this matrix. So you will get this, right? And this is what? A square plus AD plus AD minus BD plus AC plus CD plus BC plus D square. So now they have opened this bracket. Now take the difference of these two. What they did, this matrix as it is, now open this matrix like this. See, 1 minute. There is also another way. Up to here we have no problem. Up to here it is clear. Now keep this matrix as it is. So this matrix as it is. Now this is after multiplying this matrix with A plus D. Now again keep this matrix as it is. Now multiply this A into A square plus AD. We are getting this. B into A is AB plus BD. We are getting this. C into A plus D is CA into CD. We are getting this. DA into D square. We are getting this, right? Now take the difference of this minus this. You will get the finally the difference of these two matrices as the matrix A square plus BC minus A square minus AD, and then AB plus BD minus AB minus BD, and then AC plus CD minus AC minus CD plus BC plus D square minus BC minus D square. Simplify it. What you will get, some terms will be cancels out. See here what is left. BC minus A square and A square will cancel out. What is left? BC minus AD. All these terms AB will cancel out with AB, BD will cancel out with BD. So 0, 0, BC minus AD, right? So BC minus AD and BC minus AD same terms. We can take BC minus AD common. So what is left? If we take BC minus AD common, what is left? 1, 0, 0, 1, and this is what? This is an identity matrix. So what we did, actually we calculated the value of A square minus A plus D of A. Its value is coming out to be what? Its value is coming out to be BD minus AC into this matrix 1, 0, 0, 1, right? So see this A square minus A plus D of A. This is equals to what we want to prove, AD minus BC. Here we are having BD minus AC. So if we take minus common, this can be written as AD minus BC, and this is your identity matrix. Now transfer this term from right to left. So what you will get, A square minus A plus D plus A plus AD minus BC of identity. This is equals to 0. This is actually very much similar to the equations as we solved in general for the variables. We show that x is equals to 1 is the root of the given equation. So here the matrix A is equals to A, B, C, D satisfies this matrix equation, means this matrix is a root of this equation. So from this matrix we will show that the equation is being satisfied. So this is how we can prove that how a specific matrix can satisfy a matrix equation in a very similar way as we see in general cases any value of x satisfies a specific equation. So students, thank you very much. I think I should stop it here and I will continue the remaining portion of the text in the next session. Thank you very much.